All right, you guys, today we are learning about special parallelograms. Okay, so we're learning about rhombus, a square, and a rectangle. So just so you know, everything we've learned so far about parallelograms also applies here as well. So off to the side, I'd like you to go ahead and write down everything you know about parallelograms. There should be 5 facts that you need to know. So go ahead and do that for me now. All right, so let's go ahead and go through these. Hopefully we all know the first one based on the definition of a parallelogram. The opposite sides are parallel. Okay? The second one is based again on opposite sides. Opposite sides are congruent. Okay? The third one's based on opposite angles. Opposite angles are also congruent. And then we have the diagonals. They bisect each other. And then, of course, remember, C to C. Consecutive angles are supplementary. So for these special parallelograms, a rhombus, a square, and a rectangle, all 5 of these facts apply to those 3 quadrilaterals. Okay? So let's go ahead and take a look at them. As you can see here, we've got a rhombus. The rhombus is a parallelogram. That's why all of these facts right here apply. A parallelogram with 4 congruent sides. Okay, so all 4 of those side lengths will always be the same if it's a rhombus. A square is a parallelogram with not only 4 congruent sides, it also has 4 congruent angles. And if you think about it, if every quadrilateral is 360 degrees, 360 degrees divided by the 4 congruent angles would mean that all 4 of those angles must be 90 degrees. And then we have a rectangle where it's a parallelogram with 4 congruent angles. So again, same idea. All quadrilaterals are 360. 360 divided by 4 gives us that all 4 of those congruent angles are 90. Now, you have to note this. By definition, a square is also a rhombus and a rectangle. Because if you look at the criteria here, for a square, it says it's 4 congruent sides and 4 congruent angles. Isn't a rhombus 4 congruent sides? So if a rhombus is 4 congruent sides, a square also has 4 congruent sides. So technically a square is also a rhombus. Likewise, a rectangle has 4 congruent angles, right? Doesn't a square also have 4 congruent angles? So technically, a square is also a rectangle. All right, so for this example, it says we have a rhombus, and it says decide whether the statement is always or sometimes true. And it says draw a diagram and explain your reasoning. So let's go ahead and draw a rhombus, and we'll label it QRST. So we know by definition that if it's a rhombus, it's a parallelogram. We also know by definition that the rhombus has 4 congruent sides, so I know all 4 of these sides are going to be the same. Now, is it always or sometimes true that angle Q is going to be the exact same angle as S? Well, since it's a parallelogram, and parallelograms always have opposite angles that are congruent, we're going to say true. It will always be true because opposite angles are congruent in parallelograms. Okay? So let's go ahead and do the same thing with this next one. So again, by definition, we know this is a parallelogram because a rhombus is a parallelogram. We also know that opposite sides are congruent because by definition, that's the definition, right? A parallelogram with 4 congruent sides is a rhombus. So angle Q is sometimes or always going to have angle Q and angle R congruent. So if you think about this, right now the way it's drawn, this angle right here looks obtuse, right? And this one looks acute. There's only one instance where these two are going to be congruent. And that's when these are both going to be right angles. Right? For these two to be the same, they both have to be 90. Trying to make them like little boxes there. So we can say sometimes when the rhombus is also a square. Okay? All right, so in this next example, now we're looking at a rectangle ABCD. And again, you're going to decide whether the statement is always or sometimes true. It says draw a diagram and explain your reasoning. So let's go ahead and draw a rectangle, label it ABCD. And you'll notice how I drew both of these. One, I drew the traditional way that you probably learned in elementary school, where it looks like two sides are different, right? That this side length is different from this length. And then I drew it based on definition. Remember, if you actually look at the definition, it says a parallelogram where it has four right angles. So technically, the square is a rectangle, okay? So you have to think about that. It's not always drawn the traditional way. So is it sometimes or always true that AB is going to be the same length as BC? Well, it's only going to happen when that rectangle is also a square. So we're going to say sometimes. When it is also a square. Okay? So using those same two pictures, we're going to look at AB and CD. Right? Again, the definition of a rectangle is it's a parallelogram with four right angles. Technically, a square is a rectangle. So, is it always or sometimes true that AB is equal to CD? Since they're opposite of each other, we're going to say always. Okay? That's because opposite sides are congruent in every parallelogram. Okay? All right, I'm going to have you go ahead and try the U-try. So I'm going to have the substitute pause the video here for you, so then that way you can actually go through and give it a try. And then once the majority of the students are done, go ahead and press play and I will explain how to do each of these. All right, so for this first one, it says, for any square JKLM, is it always or sometimes true that side JK and side KL are going to be perpendicular? Explain your reasoning. So you can see I use the definition of a square. The definition of a square is a parallelogram where four sides are congruent and four angles are congruent. If you look at this, our sides JK and KL perpendicular. We're going to say this is always true. Because squares have four right angles. Okay? All right, so let's go ahead and look at number 2. All right, so if you look at number 2, we have a rectangle EFGH. So you can see I drew both situations where the rectangle has two side lengths that are different and one where they all are the same. Remember, again, by definition, rectangles just have four right angles and they're a parallelogram. So it says, is it always or sometimes true that FG is congruent to GH? Well, in this case, it would not be true, right? When it's a square, it is true. Okay, so we're going to say sometimes. When the rectangle is also a square. Okay? All right, so this last one says we have a quadrilateral with 4 congruent sides and 4 congruent angles. It says sketch the quadrilateral and classify it. So I sketched it like a parallelogram, but then as I was doing that, and thinking about the fact that if all four angles are going to be congruent and all four angles in every quadrilateral are going to add to 360, 360 divided by 4 would be 90. So really, I should have drawn it where all four sides are congruent and all four angles are right angles, and that would make this a square. Okay? All right, so of course we have some new information to learn here. We are learning about the rhombus diagonals theorem. So it says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So you can figure out if the parallelogram is going to be a rhombus if you can show that the diagonals are perpendicular. So if you can show that this diagonal makes a right angle with this diagonal. Okay, so if you think about the calculations you would do on a coordinate plane, how do you show that two line segments make a right angle? Well, you calculate their slope. So you would need to calculate both diagonals' slopes. And you have to show that they're going to be perpendicular slopes. And how do you show that slopes are perpendicular? You show that they're opposite reciprocals. Okay? Now we have the opposite angles theorem for a rhombus. In a rhombus, it says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So again, if you look at your picture here, this diagonal has to cut in half the angle for A and C. So those each are cut in half. Likewise, for angles B and D, those are also going to be congruent. And then we have the rectangle diagonals theorem. It says a parallelogram is a rectangle if and only if its diagonals are congruent. So if you can show that this segment AC is the exact same length as this segment BD, then you can show it's a rectangle. So we would be calculating their lengths, so we would calculate the distance. So calculate both diagonals' lengths and show they're equal. Right, that's the distance formula for both diagonals. Now we will eventually be showing these calculations on the coordinate plane. So I want you to add in something else here. So if we're trying to find the quickest way to show that a parallelogram is a square, so let's write that down. Show parallelogram, like I like to write it for shorthand. So show parallelogram is a square. The quickest way to do that would be to show that it's a rhombus and a rectangle. So that would be to show both that their diagonals have the same length and that their diagonals are perpendicular. If you can show that, then you automatically know that that parallelogram is a square. All right, so let's go through some examples. It says find the measures of the numbered angles in rhombus ABCD. So you have to remember what we learned about a rhombus. If you look back to our previous page, we just learned that in a rhombus, the diagonals bisect the angles and the diagonals are perpendicular. Okay, so knowing that tells you the angle 1 is 90. So all four of these are going to be little right angles. Okay. We also know that the diagonals bisect each other. So this is 61. Okay, and in addition to that, remember a rhombus is a parallelogram. So if a rhombus is a parallelogram, opposite angles are equal. So that would mean that angle 2 has to also be 61, and angle 3 also has to be 61. So in addition to that, we also have a nice little triangle here. right? Isn't this a triangle? So if you look at that nice little triangle, you can subtract what you know from 180 to find angle 4. So 180 minus 90 minus 61 gives us angle 4 is 29 degrees. Now technically, I know it doesn't say that you have to do this, but you could find out all of the other ones. Again, remember the diagonals in a rhombus bisect each other, and in every parallelogram, opposite angles are congruent. Okay? So another thing to point out, remember a rhombus has 4 congruent sides. So if all 4 of these sides are congruent, what kind of triangles would these bigger triangles be? Notice how they have 2 congruent sides, and both of these angles are the same. Notice how they're isosceles triangles. Same thing here. This is another isosceles triangle. So you can use things that we've learned before to help you with this as well. We also have more isosceles triangles. Look at these. Right? These two are congruent. See how they both have base angles of 29 degrees? And then you could do the same thing here. Okay, so you can use previous information to help you figure these out as well. All right, so go ahead and do the U-try for me. You can go ahead and pause the video for me and have them answer those 4 questions. All right, so hopefully you all figured these out. First thing we want to do is find the measure of angle ABC. So if we look at our picture, ABC would be this whole angle, right? So 29 plus 29, which would be 58 degrees. All right, then we had measure of angle ACB. So looking at ACB, that one was 61 degrees. Then we had angle ADC. So ADC would be 29 plus 29, so again 58 degrees. And then last we have the measurement of angle BCD. So I'm moving the page here. BCD would be 61 plus 61, so 122 degrees. All right, so go ahead and pause this again. I'm going to have you go ahead and have them do the next U-try. It says find the measures of the numbered angles in rhombus DEFG. So go ahead and pause it and then press play once you've noticed most of them are done. All right, you guys, hopefully we are done. If you look at this, again, we see it's a rhombus. So rhombuses have 4 congruent sides. So the key with this is, again, realizing you have isosceles triangles. So you're using what we already learned in class to do these problems. So that vertex angle is 118. Remember, the base angles are always congruent. So angle 1 and 3 must be the same. So hopefully you did 180 minus 118, which leaves you with 62. And then those 2 base angles must be equal. So 62 divided by 2 is 31 degrees. So angle 1 and angle 3 would be 31 degrees. Now, in addition to that, we learned that the diagonals bisect each angle. So if they're bisecting each angle, that would mean that angle 2 must also be 31 degrees and angle 4 must also be 31 degrees, which makes sense with this other isosceles triangle. In addition to thinking of it that way, you could also remember in every parallelogram, opposite angles are going to be the same, and you could subtract the 118 again from 180 and use the whole isosceles base angle theorem again to say that 2 and 4 would be 31. All right. So let's go ahead and work down our page here. All right, so this next example says, can you conclude that the figure is a rectangle? Explain. So right now, looking at this picture, I already know that these opposite sides are congruent and these opposite sides are congruent. So I can show that this is a parallelogram. But can we show that the angles there are right angles? I know it's drawn like a rectangle, but isn't this also the same information, just drawn slightly different? Is that a rectangle? So without knowing the angles, you cannot just assume that it's going to be 90 degrees. You have to actually know it's 90. So we're going to say, no, we can only assume it's a parallelogram because opposite sides are congruent. Okay? All right, next example. It tells us we have a rectangle. Right? Rectangle QRST. And then it tells us from Q to S, this diagonal is 5x minus 31. And then the other diagonal, RT, is 2x plus 11. So it says find the lengths of the diagonals. Remember with the rectangles, we just learned that 2x plus 11, the one diagonal is going to equal the other diagonal, 5x minus 31. So you solve for x, and then you plug it back in to find their lengths. So move 2x to the other side, move 31 to the other side, so we end up with 42 equaling 3x, and then 42 divided by 3 gives us x to equal 14. So then we just plug it in. So QS would be whatever 5 times 14 minus 31 is. So 14 times 5 is 70. Take away 31 leaves us with 39. And I'm assuming RT would also equal 39. But we can always plug it in just to make sure we did everything right. So 2 times 14 would be 28 plus 11, which you can see is also 39. Okay? All right, go ahead and do the U try, and then I will go through it. So go ahead and pause the TV or the screen again, let the kids try it, and then press play and I'll explain it. All right, so you can see we have a rectangle, ABCD. I did draw this rectangle as a square. Again, remember, the definition of a rectangle is it's a parallelogram with 4 right angles. Technically, a square is a rectangle. All right, so from A to C, we've got 7x minus 15. From B to C is 2x plus 25. So you just had to set those two equal to each other and solve. So moving your like terms to the same side, you should have 40 equals 5x, and then when you divide by 5, you get x to equal 8. So once you know x is 8, plug it in. All right, so 7 times 8 is 56, minus 15 is 41, and then 2 times 8 is 16, plus 25 is 41. So we get BC is 41 and AC is 41. All right, on to our last part. It says decide whether a parallelogram ABCD with vertices as given is a rectangle, rhombus, or square. And it says give all names that apply. So let's first start by plotting our points. All right, so the thing about this is you have to show and prove what it's going to be. And that's what makes it tricky, because we graph it, we're like, we definitely know it's not a square, right? We know it's not a rectangle because it doesn't have right angles. We know it's not a square because it doesn't have right angles. So it's definitely got to be a rhombus, right? But we have to prove with our coordinates that it's actually not a rectangle or a square. So the quickest way to do all of these problems is to check the diagonals. We learned that in a rhombus, the diagonals are perpendicular. We learned that in a rectangle, the diagonals are congruent. So if you can check those 4 things, you will be able to check off if it's a rectangle or a rhombus, or if it's both of those things, if it's a square. So with every one of these, you're always going to calculate the diagonals' distances and slopes. So you're going to do 4 calculations. Okay? So let's go ahead and do that. Let's do the distances first. So we'll find the length from A to C, and then we'll do the length from B to D. So A to C, so -2 minus 4, right? Because I'm using these two. And then 6 minus 0. So we end up with -6 squared plus 6 squared. So the square root of 36 plus 36. So square root of 72. Then we're going to do the same thing from B to D. So 6 minus -4 squared plus 8 minus -2 squared. So 10 squared plus 10 squared. So that's the square root of 100 plus 100. So the square root of 200. All right, so we've just shown that it's not a rectangle, right? Because they're different lengths. And therefore we've shown it's also not a square because they're different lengths. All right, so now we have to show that it's a rhombus by showing that the diagonals are going to be perpendicular. So we're going to calculate the slope of AC, and we're going to calculate the slope of BD, and hopefully we end up with opposite reciprocals. All right, so again, y's go on the top. So looking at points A and C, it's going to be 0 minus 6 over 4 minus -2. So we end up with a slope of -6 over 6, or -1. And then BD, we've got -2 minus 8, -4 minus 6, so -10 over -10, which is +1. Remember, opposite signs and the reciprocals of each other, right? Isn't 1 over 1 flipped? If I flip the top and bottom, it's still 1 over 1. So these are opposite reciprocals, so they're perpendicular, so we know it's a rhombus. Okay, so our answer here would be just a rhombus. All right, so I want you to go ahead and do the U-try. When you are done and you've calculated all 4 things, meaning find the diagonals lengths and the slopes of the diagonals, bring it up to the substitute. They will take a look, and then they will give you a worksheet for homework. Now make sure it's done. Check your answers on Google Classroom after you're done, and then make sure you bring it to class tomorrow because it will be collected. All right, have a great day, you guys.